which product are we going to make? The key here, not looking at the answers, thinking about it. So the first step, right, we have this, the first step to a Grignard formation, we have this carbon that's electrophilic. We're going to actually make it nucleophilic. And we're going to do that by adding in a metal. So this is that single-headed arrow type reaction. This is where we're going to form the Grignard reagent. So carbon 1, 2, 3, 4, 5, 6, 7. So now we've turned carbon 1 from an electrophile into a nucleophile, right? Like a carbanion. It's bonded to a metal. It's like a nucleophile now. It's like a carbanion, negatively charged carbon. So that's step 1. Step 2, we add in the electrophile. What in atom or in molecule that's on step 2, which atom is electrophilic? So 6 is the electrophile. Why is 6 the electrophile? Because it's bonded to the oxygen, which of course is electronegative. Polar covalent bonds. We learned this. 1 is my nucleophile. 2 is my electrophile. 2 electrons go there. We add in. We break that pi bond. So this is that addition reaction we're adding in. So the new bond is between which 2 atoms? Carbon 1 and carbon 6. 1, 2, 3, 4. There's carbon 6. What else was carbon 6 bonded to? Bonded to carbon 5, carbon 7, and an oxygen. 5, 7. Oxygen needs to have a negative charge, right, to balance our charge from before. So what have we created? Right, we've created a tetrahedral intermediate. When you have a tetrahedral intermediate, what do you ask yourselves? Do I have any good leaving groups? Right? Things that can stabilize a negative charge. Do you have any good leaving groups here? Off of carbon 6, I have carbon 5, carbon 1, and carbon 7. Those are all carbons. Carbon is not a good leaving group. No good leaving groups. We go on to the next step. So now we're on to step 3. What is step 3 going to be? It's just going to be protonation. All right, protonation. And that'll lead us to the final product. Number our carbons. Make sure we didn't lose any. A lot of people ask, numbering the carbons, it's arbitrary. The key to numbering your carbons, I'm not naming, so there's no right or wrong way to number it. The key, though, is if you number it this way, on one side of the arrow, you better number it the same way on the other side of the arrow, right? Don't change the numbering system. So this is the final product, this tertiary alcohol, right? It's a tertiary alcohol, right? A tertiary alcohol. Big keys that people probably didn't do, right? Recognizing how many carbons am I adding? 3. Also, numbering your atoms so you don't lose them, right? What a lot of people did, they got this far and then they wanted to add carbon 1 to carbon 5, right? That's what a lot of people had done. Got to number those carbons, number those atoms, number all the atoms. I don't care. Don't worry about hydrogen, but number those atoms. I'll get you there. So the first key to this workshop, there's a couple things I saw people having some misconceptions. The first thing we didn't do enough of was numbering our carbons. Number your atoms. I cannot emphasize this enough because you're going to start doing weird things if you don't. Don't lose your carbons. You'll see the sad face. It's like keeps me up at night. This is what nightmares are made of for me. Lost carbons, right? Things that were different here, but so this is a new nucleophile you haven't seen, but it's really similar to what you've been doing. So the key here is to recognize carbon 1 is the nucleophile, right? Carbon 1 is the nucleophile. And really, remember, any carbon bond to magnesium is like an ionic bond. It's like an ionic bond, right? And you can see, right, if you number the star materials and the product, you also see that numbering. So the nucleophile, right, reacts with carbon 3, and that breaks the pi bond. I could redraw this, and this helps you redraw it this way. you could have redrawn this nucleophile like this. If it's easier for you to see drawn like that, draw it like that. That's okay. Right? Draw it like that. So what's the product of this first step going to be? Which bond do we form? So we formed a new bond. So O minus. There's the H there. So there's 4. There's 3. 1 is bonded to 3. And 1 is still bonded to 2. Now somebody's going to say, well, wait, what happened to the magnesium and the bromide? It's just to balance our charge. It's like a salt. We just bring it along for the ride. There's MgBr plus. All right? That's why sometimes maybe if you like drawing it like this, draw it like that. That's fine. I might kind of draw it like this. Right? I might kind of always draw it like this, but so you might have to redraw it to make it like that. That's okay. So then you have a tetrahedral intermediate. And what happens? Once you have a tetrahedral intermediate, you ask yourselves, do I have a good leaving group? And if you do, what do? You let it leave. But if you don't, you do the next step, which is protonation. So in this case, the last step would be protonation. And that leaves us to, so we had an addition step, and then a protonation step. And that's what every single one of these is. The first step is a protonation, or is an addition with a nucleophile, whether it's a Grignard or a hydride. And then the second step, because there's no good leaving groups, is a protonation.